Good afternoon, everyone, and welcome back to the Energy Storage Summit 2021 edition. I hope you've been having a good day so far and have had a chance to listen to this morning's presentations, panels, and get involved in some of the networking. Do remember, if there are any sessions that you've missed, you will be able to watch them on catch up. So there is an on-demand service for any videos that you've missed live. You'll be able to catch up for up to 4 weeks after the event. So do make use of that because we've had some fascinating sessions this morning. This afternoon, we're going to move to a presentation now. So we're going to hear from Leclanche. We're going to hear from their CEO, Anil Srivastava, who is going to do a short presentation looking at how you can kind of change renewables from intermittent power sources into baseload. We've got a really exciting case study to hear from with Anil, and at the end of the session we'll take questions from the audience. So do remember you can drop questions into the chat box, and we'll try and get through as many of those at the end of the session as we can. We've also got some colleagues joining Anil this afternoon, so a really good chance to meet the team at Leclanche and sort of find out who you might be working with on projects. For now, I'd like to hand over to Anil and ask you to share your screen, please.
Thank you. Thank you, Joe. Good afternoon, everybody. Let me first make sure that I'm able to work this screen, and then we'll get started. Okay. All right, let's see.
So whilst Anil is sharing his screen, just to remind the audience members that you can drop questions throughout the session into the chat box. And as I say, we have quite a few speakers on the line this afternoon from Leclanche, so looking forward to a healthy debate at the end of the session. Anil, over to you. I'll take myself off screen so I can enjoy the session. Thank you very much.
Thank you, Joe. Good afternoon to everybody. Thank you to the organizers for giving us this opportunity, and indeed to all of you who have joined this online session. I would also like to thank my colleagues, Bryan. He is Executive Vice President of North America for Leclanche. Viorel Moga, he is our Chief Engineer for Stationary Storage Business. And Ravi, who is our Vice President for EMS Software. All three colleagues are in attendance. After I finish a quick 15-20 minutes presentation, my colleagues will join me to answer any questions you might have. We are here to talk to you about a live implementation of an exciting project we are doing in St. Kitts. I know throughout the day you have heard a lot about energy storage, how to make money from energy storage. I'm going to show you how Leclanche is making money or going to make money from this project. This project is, I'm going to take you through the overview of the project. Then at a high level, talk to you about what does it take really to implement projects of this magnitude in terms of size and complexity. Go over a little bit details about the project implementation, not a lot, but my colleagues, Chief Engineer and Vice President for EMS, they'll be able to answer any technical questions you might have. Last not the least, I would, with permission, stake a claim why Leclanche is a credible partner to implement projects of this magnitude. Let's get started. In terms of the project overview, what in Leclanche we call green power plant. We are building a green power plant combining intermittent solar energy with our battery-based energy storage system, BESS, to deliver baseload power, I repeat, to deliver baseload power to St. Kitts Electricity Company, our customer, in short, SCELEC. We are pleased to share with you, with the permission of SCELEC, of course, this project delivers 22% economic saving for St. Kitts. 22% savings, okay, for electricity. 30% of island's electricity will be delivered by this green power plant. It's not insignificant. We are very thankful to, obviously, SCELEC for signing a 20-year power purchase agreement with us, and indeed to St. Kitts and Nevis government for giving us land lease on a long-term 20-year lease basis. SCELEC has been very kind to provide us the project to site, to locate the project strategically just very close to their own power plant and directly coupling into 11 kV main bus. that makes the whole thing quite efficient, as any electrical engineer would understand. From Leclanche's perspective, if I can, without boring in too much detail, it's been more than 2 years of project development, engineering, and all bits of permitting to get to the point that we announced the groundbreaking on 10th of December last year. And we are beginning at the early stage of, if you like, start of construction. That is one part of it. The second part is a pivotal decision Leclanche made that projects of this kind, which have long-term power purchase agreement or offtake agreement, we would build, own, and operate. So this $70 million project, we are financing through Leclanche equity, as well as we are in the final stages of securing leverage. The quality of the project is I think endorsed by the fact that we are confident to secure at least 60% leverage or more. The whole contracting package done by Leclanche as a prime EPC contractor, as a prime O&M contractor, with a very credible, reliable subcontractor for the solar part of the business. That is how we have designed this project. I'm very, very excited to share more details with you, and will be very happy to take further questions towards the back end of my presentation. Let's get started. What does it take to implement projects of this magnitude? In short, it takes a lot, but I'm going to elaborate that. It's not rocket science to build solar plus storage project, but it is quite an endeavor. Okay, it's quite a complicated endeavor if you have to deliver guaranteed baseload power on day-ahead outlook basis. That is the core. I'm going to repeat, guaranteed baseload power on day-ahead outlook basis to scale. That's what we are here to do with this green power plant. So it starts with obviously understanding the customer need, studying the network, studying the grid, the load, the base, the peak, the power quality, harmonics, all of the above. And no detail is small when you're in that phase. At least that's our learning. Once you get that bit, you at least know what the customer's expectation is. Then you get down to say, how are we going about it? Earlier in the session today, I read an interesting part of the agenda of the first session this morning, which says something to the effect that bigger the project, more sophisticated energy management software needs to be. We agree with that. We agree with that. The rich set of controls, the monitoring functions we have in our energy management software is the brainchild, is the core of this project. With that EMS, energy management software, we marry it to our systems integration know-how, number of tools we have built or learning from many projects we have implemented to dimension the system, dimension battery energy storage system, the solar part of it, batteries interaction to the grid, all of the above, and you come up with the cost base. You got the cost base of the green power plant, you know the cost base of generation from the customer, and those are the two things you require to smart design a power purchase agreement. Anybody can design a power purchase agreement, I understand that. But smartly designing power purchase agreement is about delivering the benefit, dispatching the power to the customer when needed and when it's most effective. You can always deliver on best effort basis. That's no rocket science. The beauty of the design, a robust design using truly an intelligent energy management software is there. Ability to dispatch power when is needed by the customer most effectively. That is how you design competitive power purchase agreement. In Leclanche, this build, own, operate project using our energy management software, we call it energy storage as a service. We are very, very excited about the project. Let me take you through some more details of the project. Going into the details of the project here, On day-ahead outlook basis, our power plant, the green power plant we have designed, could deliver 8 megawatt, 10 megawatt, 12, 16, up to 18 megawatts of power. You would also observe this light green, if you are able to follow me on the screen towards the right. The power plant we have designed is maximizing delivering base load power, green electrons, green power during the evening peak. This is an island. Anybody would know that's when the most of the peak occurs. That's when the cost of generation is high. That's where diesel gensets are at the peak and you have the maximum pollution. That's when our green power plant delivers reliable baseload power. By the way, 41,000 metric tons of carbon emission saving is a bonus on top of a 22% improvement in cost of generation for our customers collect. I'll keep moving. I'll take you very quickly through the snapshot of how we went about the project. And if you have details of any discussions, our chief engineer, our software head of our software EMS is online, and we'll be happy to take the question. I'll take you through the full journey of pre-engineering, system engineering, detailed design, and how we will hand over the project to the customer in terms of testing protocol, training, etc. On the pre-engineering, without meaning to go take you through all the details, it's important, obviously, you start with the most basic part of it, how much solar generation we will have. The solar yield study using PV sys is an important part of it. Then you say, okay, if this is what a PV power plant will look like, how am I going to put it with the battery energy storage system, this AC-DC coupling? You estimate the size of the battery energy storage system and then say, well, I got my PV part done. I got battery energy storage system done. So what do we need to do next now? How much baseload power we will be able to deliver? Based on this PV SID study you see here, how much baseload power we will be able to deliver? Then you go on in the end and close by two important points. One is you got the single line electrical diagram over here. And then you do the layout of the battery, layout of the solar power plant, and start to make choices of equipments, which battery to use, which inverter power conversion system to use. All that starts to come into place. That's part of the pre-engineering, as we call it. Then you get down to say, all right, I got my engineering done, front-end engineering done, if you like. Okay, let's get into the detail. What will be the flow of power? What's the quality of the power, power factor? Okay, what's the quality of the power? If I may take a minute to kind of expand the screen, hopefully I can come back. Over here, you start to get into the details. What's the frequency deviation? How much power we are producing per unit from solar, from battery, battery to the grid, and solar to the battery. All those details start to come in at this stage. You also talk about operation strategy, the SCADA, what data you would acquire, how would you communicate with the grid, and then start to play scenarios on failure mode analysis to say FMEA. What if this happens, what are we going to do? How are we going to mitigate that? All that starts to come into systems engineering now. Before we take our EMS and start adapting the controls, sometimes adapt, sometimes building new control. Almost always, at least in our experience, there is a degree of adaptation. There's a degree of communication protocol we have to develop project by project based on the local grid situation. So that's systems engineering. I hope I'm not going too fast. I'm trying to keep to time as well. Then you get down to detailed design and implementation aspects of it. Common sense, you have to prepare the site very well from safety standards and all of the above. You do the electrical design, layout, substation, cabling, metering, all of the above. And one key area which comes into play here is obviously the interconnection. All of us who have implemented any electrical system or power station, you know the issues which come from harmonics and things like that. It's not trivial. More the work we do at this stage, better will be the output when the plant is in full operation. We do all of the above. At this point in time, we go ahead, do the battery enclosure, we do the EMS development, the controls, if any adoptions need to be done, new communication protocol, what is the monitoring tools we need to have, what tools the customer Scalec needs to have to look at the power plant at any given time, and so on and so forth. This is obviously stating the obvious, but there is so much of detail to be worked to build a reliable, dispatchable baseload power than to do best load solar plus storage. Oftentimes, the industry is confused between solar plus storage and green power plant. I would like to humbly remind this power plant we are building is a green power plant to deliver reliable baseload power based on day ahead outlook agreed with our customers, Skelec, every day for 20 years. The degree of diligence, degree of resilience you need to put in the design is very different than delivering power on best effort basis. It's obvious that there are a number of protocols one agrees on how to accept different equipment, be it PCS, battery, and so on and so forth. But important point is the site acceptance and system commissioning. That's where our customer comes in. That's the ultimate test. These are the tests the customers would perform before accepting the green power plant. All that is developed, documented, agreed with our customers Scalec. Hope you get a view of how we went through this journey. Anybody building a reliable power plant goes through the similar setup journey, but through this short presentation, you can also see the degree of work one needs to do to get to a reliable green power plant. Before I get into the last some minutes of Leclanche part of it, I would like to recap what we are delivering in the project. And it's important, without meaning to take slide back and forth, it's important to recap one more time. Leclanche is building a green power plant to deliver reliable, dispatchable baseload power when needed based on day-ahead outlook agreed with our customer, St. Kitts Electricity Company, Scalec. The project is designed in a way that we have not only financed the equity, we are close to securing senior debt to leverage at least 60+% senior debt. In an island country where the sovereign risk is a little bit more than what you would see in OECD countries. It's relatively easy to get leverage in OECD countries. Try and get 60% leverage or more in an island country. It is quite challenging unless the project is designed very robust, the power purchase agreement is robust, the whole operation strategy is very robust, all of the above. That's what we have set out to deliver. In St. Kitts, we believe humbly that this will set a reference benchmark for the industry to not only in St. Kitts, but all islands in the Caribbean, or for that matter, all islands in the world. With that, I would like to conclude by a couple of slides to say why Leclanche? What's our credentials? What's our, if you like, claim to fame here to win such a project and implement? Here it is. First and foremost, we went commercial in this business only in 2018. Okay, so we are talking about 2018, 19, 20, 3 years behind us, less than 3 years. We have implemented a number of projects, all adding up to 120 megawatt hours of implementation. By choice, my leadership team is on the call. By choice, we decided to build different applications, different type of grid ancillary services, microgrid, fast EV charging, and then combining some of the applications. The people during the day have called them revenue stacking, multiple revenues, and so on and so forth. What's being talked about, we do it. We do demand charge adjustment with fast EV charging, in this case, electric ferry in Ontario Lake, Canada. In the project in St. Kitts, the one we are talking here, It's not only delivering base load power, we also are doing spinning reserve. So what you have heard during this other session during the day, we confirm that is the way to make money. That is the way to make money with energy storage. Okay, smart, robust, flexible energy management software with multiple controls and good monitoring tools. Oftentimes people use the word artificial intelligence in EMS without going into the buzz of it. Every energy management software, a good one, needs to have artificial intelligence. You need to have predictive algorithms without which you cannot build smart green power plant. Ours does true. So with that experience base, a little bit more details, energy storage as service, that's what we call it in Leclanche. Our energy management software already has number of predictive algorithms based on artificial intelligence. We don't go about doing blah, blah, a lot of talk. For us, it's a basic requirement. That's what we do every day with our energy management software. By design, the EMS is multi-platform, different type of batteries, Leclanche batteries, which we build ourselves for our transport business, batteries from LG Chem, now LG Energy Solutions, batteries from Samsung SDI. We have experience of using all those batteries from CATL, different 3-4, what do you call, inverters, power conversion systems. By design, we have kept our EMS platform multi-battery system, multi-PCS is by design, even though we build our own battery system. With that, I will try to probably stop here, and so that there is some time to get questions. I'll stop here in terms of who are the customers who trust us, what are the projects we have delivered. I can't go through in the given time with all the projects, but you see where we have implemented, delivered projects, and who are our customers. They are all over the world, from North America to Europe to few projects in India. We will provide through event organizers about our energy management software details in this deck, whatever we can share in the public domain, as well as our unique container design, which we call the block. In the interest of time, I'm going to stop here, and maybe it will be a good time, Joe, to get some questions. I will stop sharing, and thanks for bringing my colleagues online. Thank you.
Super, thank you very much, Anil, for sharing that. I think it gives the audience a really good overview of the project. I have seen a few questions come in, both of them centered around the PPA. But I mentioned in the chat that we do have a panel of experts who worked on the project here to answer questions. So we are joined here by Viorel Moga, who is the Chief Engineer, Ravi, Karthik, Vice President for EMS Software Development, and Bryan, who's the Executive Vice President for North America. So it might just be worth maybe, gentlemen, introducing yourselves and saying a little bit sort of about who you are and what your role in the project was. Audience members, you can drop questions into the chat. And as I say, we've got enough time to get through many of them this afternoon. Bryan, can I ask you maybe to take the floor first, please?
Sure. Thanks, Joe. And yeah, just a quick introduction. Been involved in the project for quite some time. Kind of led the efforts of the contracting and so forth for this project and the development. And then, as we've, I'll just Viorel Moga, is our chief engineer, has been doing the principle around the design and all the implementation with the grid and with the utility. And Ravi is our leader for our energy management software system development and implementation. We have some questions.
So,
Joe, we have some questions. Shall we start taking them?
We shall, yes. So I can see the first question from Thomas Sanchez asks, what kind of guarantees does Leclanche offer in the PPA agreement?
All right, Bryan, why don't you take that on?
Yeah, the PPA offers a kind of a daily guarantee of baseload. There's a certain level of baseload capacity that we're able to guarantee. Obviously, it depends a bit and fluctuates on the projected solar output, but averages over the year to a certain level of baseload capacity that we provide and deliver.
Bryan, it's fair to say that it depends on the day-ahead outlook. We agree with the utility.
That's correct. Yeah, we do day-ahead forecasting, and then we can establish a baseload profile for the following day.
Sense. And there was a follow-up around the structure of the PPA. So was it take or pay, or has it got different peak and non-peak prices?
I'll still leave it with Bryan. He negotiated the PPA.
Yeah, sure. The PPA is a kind of take or pay. I mean, we get paid for everything that we produce up to a certain level, and so that's the objective for any generation facility is getting paid for what we produce, and that's the design, and it fits within the context of the utilities load, and that was critical to make sure that what we could deliver and when we delivered was at the adequate and the appropriate time, so to fit within the context of the load requirements for the utility. So it's a savings perspective across the board.
That's super, thank you. I have a question here from Calvin Wong, who asks, what is the ESS augmentation strategy set by Leclanche over the 20 years?
I'll take I'm not sure what augmentation strategy, it's a very broad term. If you can put a follow-on question, I'm happy to take on. But if you're talking about around what we do in EMS, just to recap, we own our own energy management software. And there is a current roadmap, and there is obviously a robust roadmap. We are tending more towards getting into machine learning, which we haven't done a lot. Artificial intelligence predictive algorithm is in. We are right now focused more adding the machine learning part of it. That's key part of it. And the second aspect is the block. I'm going to stop. Ravi, do you want to add anything?
If I may, Anil, augmentation, my guess is that the question is related to battery augmentation. So for this project, the answer is yes and no. Part of the battery is designed to live for 20 years. However, part of the batteries is designed for 10 years. And after 10 years, we will be replacing the entire module, entire battery. The person who put the question probably knows augmentation is tricky as the technology advances very fast. So at the time of augmentation, you really have to group the batteries of the same life together and bring new batteries in a different module. And but for this project, again, that's the plan. Some of the battery was designed for 20 years.
That makes sense. And I think that kind of hits the nail on the head in terms of what Calvin had in mind. So he's followed up saying, ESX augmentation strategy refers to your plan to maintain performance of the storage system over its life. So that is, kind of what he was gearing towards there. I have a question here from Andrew Turner. He said, hi, were you aware of any other generation options considered by St. Kitts? What convinced them that battery should be the solution?
Viorel?
I know there was consideration for wind. The solar made sense because of the location, the land that was available. It's the battery is really, that was our strategy with solar by itself. You stabilize the existing grid. So our approach was to combine solar with batteries and provide a base covering a base load. So did that answer your question?
I hope.
I think so. Andrew, if you have a follow-up question, do feel free to drop it into the chat and we can come back to. He says thanks. Last question, I think, before we kind of draw the session to a close. Question here from Paul, who asks, what lessons have you learned from these projects that would shape future roadmaps? And I guess maybe, can I ask you to add on a point of what advice might you give to people around these kind of projects?
Did you say the last part, what advice? I think we will
I think
stay
it might
with,
be good to...
we'll stay with what lessons we have learned. I think we are humble enough to say we can't advise. We'll share some thoughts, if you will. We are still learning the lessons, to be honest with you. I'll be frank and candid. The time it took for us to do the whole system study and the permitting in islands was a lot longer than we had thought. Okay, if I didn't say that, I won't be honest. Okay, so from permitting point of view in this part of the world, and one has to really give a little bit more time than we are used to doing this in Europe or in the US. Okay, that's more of a general comment, if you will. There is a lot of lessons we have learned. One thing is clear to us increasingly, that if we can deliver more baseload power, okay, economic case sits very well. One doesn't have to, this is my view, Bryan, you can jump in. One doesn't have to think to say it has to be 100% replacement on day one. We are starting with 30% today. As we can deliver that baseload reliably for a couple of years, we are confident, not overselling, okay, we are confident this is going to go up much higher. At that point in time, the point where Viorel was making, we don't rule out combining other sources of renewable, such as wind, and I don't rule out geothermal, ultimately to get to where my personal goal is 100% green electricity. But we are not yet there. The architecture, the vision we have, if we have built the architecture that way, we've shared the vision with our customer, but we'll go about it progressively. No need to jump on day one for 100% grid forming and put the whole island at risk. Okay, but as we learn, we know what the load pattern is, we learn the grid, we will increase the percentage of renewable. I don't know if Bryan, you want to add anything else?
I think you stated that very well. It's a blend, and it takes implementation time to take on a full challenge of renewable, 100% renewable, and that requires multiple generation sources, like you alluded to. The batteries become the glue to the puzzle as a whole, and that combined with the software systems really help integrate all sources of renewables and existing generation as well. So it takes the case that it uses the software to implement that over the 20-year process that we're talking about with this project.
Okay, gentlemen. Well, I think we're just about out of time, and we have kind of gone through all of the questions that the audience dropped in. I would remind the audience members that you can connect with speakers, sponsors and other delegates on the Events Air platform. So when you log into that, you can see the full attendee list, you can message other participants, arrange one-to-one meetings with them, and of course you can join them for sort of networking during the speed networking sessions and the other social functions. But thank you ever so much for sharing the case study there. That was a really interesting project to hear about.
Thank you. Thank you to you, Joe, and all of you online, and to my colleagues. Have a good day.
Thank you, everyone. Have a lovely afternoon.
Bye-bye.
Good day. Bye.
Bye.